Good afternoon, everybody. We are starting the chapter alcohol, phenols and ether. In that chapter, alcohol as well as the phenol, all the reactions of alcohol and phenol are completed. Now, in this lecture, we are discussing about the ether. Here we know that the ether means the alkyl groups, two alkyl groups are attached or bonded by this O. Here bond, O bond. It's our ether. Two types of ether we are discussing into the last lecture. Here it's our simple ether. Also how to prepare mixed ether we see in this lecture. Simple as well as the mixed ether. Now in this lecture we discuss about the preparation methods of this ether. There are different preparation methods of ether. Preparation of ether. From that, today we discuss the first method of preparation of ether is dehydrogenation of alcohol. Dehydrogenation of alcohol. Now in that name we understand what happen in this reaction. Dehydrogenation means removal of a water molecule. Sometimes doctor tells us you have a dehydration. That means in our body the water will becomes less and less. Similar to that, dehydrogenation of alcohol means removal of water molecule from this alcohol. We see the reaction, then you understand how this dehydrogenation process will be done in this preparation of ether. When alcohol is heated with dehydrogenation reagents, there are different dehydrogenation reagents like sulfuric acid or hypophosphoric acid. Now these are used in this dehydrogenation reaction, then we are getting our ether. Firstly, we are taking twice molecules of our ethyl alcohol. From this alcohol, therefore we are taking twice molecule of ethyl alcohol, C2H5OH. It undergoes the dehydrogenation process in the presence of dehydrogenation agent H2SO4 or hypophosphoric acid. It also requires the heat up to 430 Kelvin. Heat is required. In that reaction, removal of water. Therefore, we write here minus H2O because dehydrogenation process will be occur. But we see in that reaction. Here we are getting a ether. This C2H5OH. Ether, therefore that alkyl group is attaching to our O bond C2H5. Here we are getting diethyl ether. Also dehydrogenation, that means water will be removed from this reaction. How this reaction will be done? We simplify this, then you understand. Here we are taking two molecules. We write these two molecules separately. Now what happens when these two molecules are heating with this dehydrogenation reagents? This HOH will be given out or removed from these, and see here C2H5, C2H5 and one O will be remaining. That's our ether C2H5O, C2H5. It's our ethoxy ether or a diethyl ether. The IUPAC name, its common name and IUPAC name of this compound is ethoxyethane. Also, this H2O is given out from this reaction. So, that type of reaction are known as the dehydrogenation reaction. It's our ethyl alcohol. Now, if we are taking one molecule of this ethyl alcohol, in that we can't get this ether. That one molecule of ethyl alcohol is converted or on the process of dehydrogenation that produces ethene. See the reaction, then you understand. It's occurs into the primary alcohol. If we are taking the example of a secondary or a tertiary alcohol, then it requires more and more heat to produce that of ether. Now, for one molecule of ethyl alcohol, C2H5OH, it again undergoes the dehydrogenation process in the presence of our catalyst. It also requires the heat. Now what happens in that? Here, when we are heating this ethyl alcohol, dehydrogenation process will happen here and ethene will be produced, not ether. See here. C, here 5 hydrogens are attached to these 2 carbon, and for this carbon OH group is attached. Now see here, these are dehydrogenation process, that means removal of this water molecule, and that single bond is converted into the double bond, therefore its ethane will be produced. This is the dehydrogenation of alcohol, that means preparation of our ether. Preparation of our ether. Now, second preparation method of the ether is Williamson synthesis method. The second one method is Williamson synthesis method. Williamson synthesis method. This is our name reaction, because this reaction or preparation of ether by this method is known by the scientist name Williamson synthesis. Therefore, it will ask in an exam, write the preparation or mechanism of the Williamson synthesis in this way, because of this name reaction. Now what happened in this reaction? The simple as well as the mixed ether can be prepared by using this method, both ethers, simple or mixed ether. We prepare by using this synthesis method or a Williamson synthesis method. Now in this method, if alkyl halide are treated with, what I say, alkyl halide or treating with, if we are taking the alkyl alkoxide or if we are taking the sodium phenoxide. We are taking the sodium alkoxide or sodium phenoxide. Depending upon that, which ether will produce in that reaction, we will see. First, I will write the reaction, then you understand how that reaction or how that synthesis will be done here. Simple reaction, first we write Rx. It's our alkyl halide. That alkyl halide, we write both the reactions simultaneously. That alkyl halide are treating with. First, if we are taking the sodium alkoxide, or we also write the sodium phenoxide. Here we are taking the sodium alkoxide. The sodium phenoxide, because this phenolic group is attaching here. Now from this first reaction we are getting ether. That's our simple ether plus NaX. And in this reaction I will explain simplifying this. But first we write the reaction ROAR plus NaX. After simplifying this, we will take examples apart from this R or this Ar. Now first, if we are taking this one, here this R and this H, from that for the preparation of the ether, this Na is attaching to that of X, and this O and R are attaching this R here. See here, this NaX. And what happened? That Na goes back with this X. That means our halide. With that halide, it's have a positive charge, it's have a minus charge. Nucleophilic reaction will be happen here. Then it's a backward direction reaction. These two are same alkyl groups are attaching. So here we are getting a simple ether. Simple ether. Now in this we are taking the phenoxyl group here. Here also this X and Na are combined each other, form this NaX, and these are attaching to that one part. This Na will be goes out, oxygen will be attaching to that of Ar, and ROAR, it's our mixed ether. Mixed ether. We discuss this reaction into deep. In your exam, if they asking explain the Williamson synthesis, then you will write this reaction or next one. But if they ask as preparation of tertiary butyl methyl ether, what I say? Tertiary butyl methyl ether. Then also you write this Williamson synthesizer reaction or preparation of ether of that Williamson synthesis. How they ask we can't know, but both are same. If they asking Williamson, then write this reaction. If they asking how to prepare the tertiary butyl ethyl ether, then also you will write this reaction. Now we will write the reaction. In that reaction, if we are taking the sodium butoxide, tertiary butoxide in that reaction, sodium tertiary butoxide is react with our methyl bromide. We are taking the methyl bromide, methyl chromide, any other of halide from that. We are taking the methyl bromide. Then we are getting our tertiary butyl methyl ether. We write here reaction. Then you clear that we are taking the sodium tertiary butoxide. Sodium is present. You clear that. Butyl group here. CH3, CH3, CH3. 4 CH3 are present. It's a butane and a oxygen is present here. So it's become a butoxide. Name of that compound is sodium tertiary butoxide. In that reaction, if this sodium butoxide is treated with our methyl bromide, CH3Br, it gives C, CH3, CH3, CH3 dash O dash CH3 plus NaBr. It's our tertiary butyl methyl ether. And it's our sodium bromide. Now here how it will done we see. In that sodium tertiary butoxide, that Na having plus charge is react with this Br minus charge, and this CH3 is attaching to that one part. So here see, two separate groups are attaching to that of a O. It's our mixed ether. It's our butyl group. It's our methyl group. We write a butyl methyl ether. Name a nomenclature. In nomenclature we discussing like these examples. It's a tertiary butane. Tertiary butyl here. It's our methyl group and oxygen. These groups are attaching by this oxygen, so it's our ether. And one more byproduct is present in this reaction. Very simple reaction. If you understand how it will be done, that means how Br will attach to that of Na and which group is attaching to that of O, then you understand very easily, right? The explanation of this reaction, of this preparation of tertiary butyl methyl ether. Very simple reaction and it's a very important reaction also. Now it's a primary. We are taking the primary halides. If we are taking the secondary as well as the tertiary alkyl halides, if they react with this our sodium alkoxide, then it produces not the ether, it again gives our alkene. We write the reaction, then you clear that. Here we are taking tertiary butyl chloride or bromide, we write here. Chloride, tertiary butyl chloride. We are seeing the examples of secondary or tertiary tertiary butyl chloride or tertiary alkyl halides. It is treated with sodium ethoxide. We are taking the sodium ethoxide or methoxide. Here we are taking example of a sodium ethoxide. C2H5O Na. This sodium ethoxide when react with this tertiary butyl chloride, then we are getting the butene. That means alkene will produce here. This bond CH3, C, CH3, CH3. Here double bond CH2. Double bond CH2 plus one more product here produce C2H5OH, that means our ethanol, and that Na is attaching to that of a Cl, NaCl. It's our butene because the presence of this double bond. It's our butene, it's our ethyl alcohol or ethanol, and a sodium chloride also the byproduct produces in this reaction. See here what happened. This Cl is attaching to that one, and one H from these are attaching to that of O. Therefore, this compound C2H5 will be produces in that, and here we are getting CH2. That carbon is attaching by the double bond. Double bond is present, so it's our alkene. There are 4 carbons, so name of that compound becomes a butene. Now, its are the reactions of preparation of the ether. If we are taking an example of a aryl halide, these are the example of a alkyl halide. But if we are taking the aryl halide into the preparation of a ether, it cannot show of the Williamson synthesis. That aryl halide cannot show this mechanism or this method. Williamson synthesis method cannot be shown into the aryl halides. There are 2 reactions of a preparation of ether are most important. They will ask in your exam, so you prepare carefully. Thank you.